and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Kevin Buckner.
Thank you, William. OSP, a case study, Organic Solderability Preserve. This is the what you need to know portion of OSP. Why? Well, because knowing can save you a lot of money. It can save you a lot of time, and it can save you, as we found out, some real big headaches. Okay, so the OSP, the Organic Solderability Preserve, and I'm going to shorten that to OSP because it makes it a lot easier for everybody. The OSP is a PCB surface finish that protects copper from oxidation and corrosion during storage and handling. It's a very thin organic coating, typically 0.2 to 0.5 microns thick, that is applied to the copper circuitry of a printed circuit board. Now, this ensures good solderability for your components to the copper pad. The OSP dissolves during the soldering process, and that allows that solder to make real good contact and give you a good connection with the copper pad. So when we look at this, we all know about the PCB, the substrates. We all know about the solder mask. We all know about the copper pad. The OSP is a little coating right there you see on top of that copper pad itself. So OSP finish problems, well, they primarily involve issues with solderability. Now, that's due to oxidation or removal of the thin organic coating itself. Some of the common problems that you see is uneven or a coating thickness issue. Oxidation could also be caused by humidity or prolonged storage if you have it in your storage facility for a long time. For this example, we're going to talk about water wash or chemistry wash on misprinted substrates. Right? So excessive water washing, if you wash your board multiple times in water, you can lead to insufficient protection or poor solderability because you remove the OSP. But with chemicals, the OSP will be degraded or removed really quickly. So what happened here with this case study? So as typical, engineers are tasked, if you will, to lower costs. Because we all know that boards are never designed to be cleaned. There's processes that take place, and it's always about, can we produce this part for less money? In this application, they were running about 6,000 boards a week, knowing that 5,000 of those boards were going to go into process, get the placement of the components, go through the reflow, and then go into the assembly. They knew that they had about 1,000 misprints that would be rejected and put off to the side. Those would need to be washed or cleaned, if you will. There's other things that we can help with in that misprinting process or the printing process that is creating the misprints. Engineered solvents on the underside of stencils would be one of them. What we offered here was our Aquanox 4618, a very reliable chemistry used in inline cleaning applications. Now, we decided to run this at about 8% concentration. We ran in an inline machine at 1 foot per minute, running at 145 degrees F. Now, you have to understand this is not a standard inline machine as far as configuration, because the wash tank was actually hooked up and had external filtration on it, which helped with keeping those solder balls in the filtration, if you will. So they didn't find their way back into the machine and go back through the wash pump or even into the rinse area. So we tried to isolate it with filtration. Running at these parameters, we passed all of their cleaning trials, if you will. What we had to attain, we attained. We didn't affect the solder mask. We removed all of the paste. We gave them a very clean product. Now, that's really the good news. What happened next was, well, not only a surprise, it was a surprise to me, but it was also quite a big problem. So QC takes those boards and they inspect using probe circuit testing. So they have a couple of points, they use probes, they touch those 2 points, they run amperage, wattage through the circuitry itself to make sure that they have a complete circuit. And they do this on non-populated, non-pasted copper pads, just to make sure everything is copacetic after it's gone through the wash process. It was not. They started having some issues. So what we did was we did a simulation. So we took a board, ran it through the printer, printed it, took it offline, ran it through the cleaning process, and then reintroduced it back into the reflow process and run it through their profile on their reflow machine. It was at that point when it came out of reflow that we noticed there was a lot of oxidation on the copper pads. And that oxidation was actually preventing that contact of the probe tester from getting good results and testing out as a pass on any of the misprinted washed reflowed boards. So looking at the process, what copper oxidation actually looks like. Here you'll see a misprinted board. And it's obviously it's a misprinted board because you see how the paste is not released completely. You see you have smears. You see you have smudges across the board. So this was actually taken out of process. These are the 2 pads that we're looking at for the inline probe testing. As you can see, this is how the board came out. You can see there's no effect to the solder mask itself. You do not see any of the printed solder paste left on the boards. When we look at these 2 pads, you'll see there is a nice, bright, shiny finish on those 2 pads prior to washing and reflow. After it went through the washing and the reflow, you'll see a much, much darker type hue, if you will, sitting on top of these pads. That is actually the corrosion that is being created through the wash process using the 4618. Now, some of you have already jumped ahead and you can see this pad right here. You know, I ran some of these trials before and I saw these same issues, different chemistries, in an ultrasonic type process. I put it down to a staining, if you would, maybe an incomplete rinsing or something along those lines. But now after seeing this case and working through this case study, I believe that we were actually affecting the OSP. We were actually removing the OSP and allowing some type of corrosion to build up on those copper pads. And while it's never been validated, it has gone back into our lab and it is going for further evaluation to see if we can clearly identify that that is truly OSP removal and some type of corrosion. It's not all bad news, right? You know, what should you be looking for if you're cleaning any type of flux before a reflow process? Something like our Aquanox 4382. It's a fantastic chemistry. Now it can run at a lower concentration, right? So it can run between, we ran it at 5 to 7% concentration with the goal being around 6. We still ran at 145 degrees. But what the 4382 has is it has an OSP-like material. So what that does is help protect the integrity of the OSP that's actually on the copper pads themselves. So you don't strip it all off, you maintain the integrity. That's very important. One of the bonuses with the 4382 is it actually works with the analyst system. So you get that manageability, if you will, of your chemical concentration and your traceability that comes through by using something like the 4382. And that's what we switched out the 4618 with. What's the best news on this thing? Well, OSP is very important, right? It's an important component of the entire PCB manufacturing process, and that needs to be preserved. We found out that there are problems if you don't preserve that. Finding the right balance of cleaning agent and your process, inline, batch, ultrasonic, is very, very critical to your entire process. Now, as we mentioned before, there may be other elements of your process which need to be evaluated. You know, I think some type of engineered solvent in the printer itself and spraying on the bottom side of the stencil will help them, give them a better release and give them a more secure, a better looking pad, if you will, as the solder's been placed on it, but that's something that we can work with and really solve a problem before it becomes a problem. Just have some basic understanding of OSP and how it works and how we can help you maintain the integrity of the OSP. Some of the frequently asked questions on this topic, well, can I reapply the OSP if I strip it off the copper pads? Yeah, of course you can. It can always be reapplied. What you need to make sure in that application is that you don't have some type of corrosion that's already formed on the copper pad itself. The reapplication of OSP is a simple dip process, and it attracts itself directly to the copper pad. So yes, it can be reapplied. I know I must wash my misprints. Can I just have the thickness of the OSP increased knowing this? No, you can't, because what's going to happen is you'll put more OSP onto that copper pad. It can harden, it can crack, and worst of all, it could have some type of reaction with the reflow process and the solder paste that you place on top of the component place, and then the reflow, it could have some type of adverse reaction with that process. That's even worse than what we're dealing with. Is OSP easy to damage? No, I don't think OSP is easy to damage. I think its integrity can be affected. We always stress, very important to wear gloves and maintain a clean working environment. Fingerprints, oils, sweat that comes off hands. Can that affect OSP? Absolutely. You can't really damage it, but you can affect the integrity. Do I need to be concerned with my solder paste flux for compatibility with the OSP? Absolutely. You should be running testing before you choose a specific OSP or a specific solder paste and flux to make sure you have compatibility between those two products, to make sure that you're getting the best bond that you can between the solder pad itself and the soldered component going onto the board. Probably more than everybody ever needed to know about OSP, but it's our job to share, to help increase knowledge and basically just understand what's going on through all of these processes. So with that, OSP, I'm going to turn it back over to William.
Thanks, Kevin. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in this session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.